We're going to talk about the causes of anthropogenic climate change. Anthropogenic means anthro, man, genic, to cause. So climate change caused by man. It's worth noting that this 10 gigatons of carbon per year is small compared to the amount of carbon in plants, in the soil, and in the atmosphere. And there are huge turnovers of carbon dioxide in terms of photosynthesis, respiration, and decomposition. However, what we have going on is we are consistently adding a small amount of carbon every year, and it's accumulating. It's worth noting that it doesn't all go into the atmosphere. Some of it goes into the oceans. About 60 years ago, we began measuring carbon dioxide concentrations in the atmosphere, here in concentrations in part per million. And what we see is a sawtooth behavior that's very strange. It's an annual oscillation. And that's because there are more plants on land in the northern hemisphere. And so in the summer, they grow more leaves, pulling more carbon dioxide out of the atmosphere. In the winter, the leaves die and decompose, releasing more carbon dioxide. So these peaks correspond to the end of winter. However, these small oscillations ride on a consistently increasing curve. That's the result of human activities. So we can trace these back using ice core samples that you dig out of the ice, because when water freezes, it locks in at the atmospheric concentrations of the gases. So you can look at the abrupt rises in these three different greenhouse gases from ice core data. And we can look at over the 10,000 years, boom, over on the right, we have a different kind of measurement, radiative forcing. What is radiative forcing? It's the amount of effective heating that the gas does by absorbing and reflecting back the Earth's infrared radiation. And it's in watts per square meter. So for CO2, you get a positive 1.5 watts per square meter. Ozone, black carbon, because it absorbs light. We also see clouds and aerosols reflect the sun's rays, so they have a negative radiative forcing. It's worth noting that oscillations in the sun have had a very, very small effect. So when we add all these up, we get about 1.6 watts per square meter. What this means is if you took a 1.6 watt light bulb, like an LED light, and you put it every square meter over the whole surface of the Earth, it would warm the Earth up just a little bit. And that's what's going on. Feedback mechanisms are how the climate responds to change the climate even more. For instance, water vapor. The more you have water vapor, you warm up the land. This increases evaporation, and that gives you more water vapor, which gives you more warming, which gives you more water vapor. So that's a positive feedback mechanism because it propagates itself. The same with snow. As Arctic regions warm, they melt, and instead of having white, now you have a dark color. And this absorbs sunlight, which makes it warmer, which encourages more melting. For this reason, it's very important. We in San Luis Obispo have about 1 degree Fahrenheit increase in temperature, but in the Arctic regions, it's 5 degrees. So for clouds, it's interesting. They have both a positive and a negative feedback. The increased water vapor causes increased cloud cover. This increased cloud cover causes less warming because it reflects the sunlight. So that's a negative feedback mechanism. However, it also absorbs infrared radiation during the night, and this causes more warming. So which one of these two wins out? So you have people studying this and modeling the climate with computer models. Here we see the results of these different computer models. The width of the lines represents the uncertainty of what the model predicts, and this is the changes in temperature over the past 100 years. The black line represents the actual measured temperature increase. The blue line represents what the temperature should be if we just look at volcano and solar oscillations. And the red line includes anthropogenic sources of greenhouse gases. And we see there is no way that this blue line matches the data. So from the models, the scientific community has concluded that yes, human beings have caused a significant change in the temperature. So by comparing the model with actual observations, we can verify that our model is doing a good job. What do we do now with the model? Well, the model now can be used to predict what will happen in the future under different scenarios. And so here we have different scenarios of greenhouse gas concentrations: 400 parts per million, 600 parts per million, 850 parts per million. And this is the global surface warming as a function of the different centuries. And these different colors represent, again, different scenarios. This is the business as usual. And these are different mitigation strategies where society works together to limit the greenhouse gas emissions. Okay, so let's make sure we get this straight. We want to distinguish the greenhouse effect from the ozone hole. The culprit: here are your greenhouse gases. The ozone hole were chlorofluorocarbons. The source: energy conversion, industrial agriculture. For the ozone hole, aerosol propellants and refrigerants. What did it do? It's absorbing the Earth's radiation more. It preferentially absorbs infrared radiation, which is what the Earth is cooling itself by. The ozone hole, the CFCs, destroy the ozone in the atmosphere. The result? Greenhouse effect: the Earth gets warmer and we have climate change. The ozone hole: the sun's ultraviolet rays penetrate the atmosphere more. The problem: the greenhouse effect causes climate change. Here we have global sunburn, or personal sunburn if you happen to be out in that sun. The solution: okay, and this is the key. The ozone hole, we have a chemical fix. We use different refrigerants and different propellants that don't destroy the stratospheric ozone. However, here we need to change our lifestyle and not emit these greenhouse gases. We don't have a technology fix. So the disposition is, we've pretty much solved this problem, but this is getting worse, and it's getting worse at a faster rate. So this slide itself is a very good summary of the greenhouse effect, or anthropogenic climate change. Please familiarize yourself with this and be able to distinguish it from the ozone hole when you go to that cocktail party and strike up that conversation.